Hello, my name is Mrs. Perez, and I chose the teaching practice of implementing tasks that promote reasoning and problem solving. I wanted to find a task that would help elevate my students' thinking during what's normally a very procedural and drilled skill, operations with decimals. The task I chose was the crab walk relay task. In this task, students are given 12 finish times in a classroom. They then are helping Mr. Fair, the PE teacher, group these 12 finish times in 3 groups. The goal is to make these 3 groups as equally matched as possible. The crab walk relay task addresses the SOL standard 6.5C. Students will solve multi-step practical problems involving addition, subtraction, multiplication, and division of decimals.
You have team 1 has 24 seconds, team 2 42, and team 3 46.
Team 2 is 42. No. Team 1.
Yeah.
Oh yeah.
You're reading it. So, yeah, I am too. So here's my question. If you were trying to be on a team, which team would you want to be on?
Team 1 has the fastest time.
Which is which one?
Team 1. Team 1.
I would agree. I would want to be on team 1. Mr. Fair, I'm reading right here, Mr. Fair wants each of the 3 relay teams to be as equally matched in total times as possible. Do you think there's a way that we can get them, I don't know, are they equally matched?
Maybe we could divide them, like find the average of what they are. That might make them a little bit equal. Yeah.
I guess, are you satisfied with these teams?
So like divide all of these by 4. But the teams do seem equal. Well, team 2 and team 3 seem pretty equal. They're only a little bit apart. Team 1 is just like team 1 is like 20 away.
I mean, that's like almost, how much difference is that? That's like a...
That's like twice that's 46.6 is basically 224.
Maybe
almost twice, yeah.
Maybe we could switch one of the people from team 3 to team 1. But team 2 is like in the middle of them, so it's like the middle number.
So you want to work with the extremities, what we would call the slowest team and the fastest team?
Yeah. I think this might have to tie in with like statistics. Or like the middle team is like... Maybe we should like take someone from team 3 and move them to team 1.
What do you mean when you're saying middle team?
I mean like, it's like... The time in the middle. The time in the middle.
And you want to change that one, or you want to keep it the same?
No, we want to change team 1 because we think that team 1, team 2, and team 3 are pretty similar.
Is that what you were saying?
We could change
to keep
the
it? Okay.
slowest person from team 3 to team 1. Yeah, let's see how that works.
Okay, I'll come back.
Okay,
the slowest person from team 3 to team 1. Okay. Go ahead.
So we rounded all the numbers, all the decimals into whole numbers, and we added them all up and divided it by 3, and we found out each number needed to have 42. So we messed around with the numbers, and we got 42 by having these numbers for each team.
Okay, so we have them equally at 42 seconds rounded, right? Yeah. Rounded times, we have them equally at 42. Now, is there a way that you could make your answer more precise?
By not rounding it.
Okay, so you have 3 teams. Why don't we go back and add our non-rounded numbers and see if they're all the same? Okay, awesome.
This one would be the greatest. So team 1 would have the greatest.
Yes,
Team 3 would have the middle amount.
So he's using symbols. The symbols greater than or equal to. Less than, greater than, or equal to. So how could I write those numbers this way? How could I use those symbols with your totals?
This would be greater than these two.
Okay, so you would do the greater.
No.
Very good. But it would go in between it, right?
yeah.
So it's a sentence. 42 and 22 hundredths is greater than 41 and 44 hundredths. What about this one? 41 and 44 hundredths?
Would be less than.
Okay. Very nice, ladies. Very nice. Okay.
So I switched 8.7 because my original total was this, and this was not fair at all, and this wasn't really either.
Which team would you rather be on in this one? Really? In the slow team?
Oh, never mind, this one. Sorry.
Ah, okay. Remember, the
Sorry,
lower
yeah.
numbers are faster. That's okay. Okay. What about up here? What did you do?
So, I switched 8.7 1146 because I wanted to switch their lowest number with this one so that we can make this team like faster and more balanced. So then I went on the back, and because it's 11 minus 8 equals 3, so I did minus 3 because there's no point for subtracting 11, just subtracting 3, so I did that. Got 4116, and I added 3.46, and I got 4073, and it's like balanced by like out by a second.
Very, very close. Can you draw an arrow so I make sure I look in the back? Draw an arrow, and then I'm gonna collect it. What were you gonna say, ladies?
I was just going to say that I got each one to the same beginning decimal number.
Neat.
Because before, I rounded each decimal to the closest and sorted each team by there. So I could add them and see which ones were closest. And so the 42 was the lowest one, but this one was originally a 36, and this one was a 46. And so I kept changing. I kept drawing a different number each time from each team. I kept swapping numbers from each team until I got the closest number in range, which is all 42.
Pretty neat. Pretty neat. Pretty even.
Do I have to write my name on it?
Yeah, girlfriend, write your name on it, please. Bella, how did yours sort out?
It didn't really work, but I tried to do the method, the 4 people and so on. But these team 1 and team 2 were pretty close, except for team 3.
No one wants to be on team 3, right? Okay, well maybe there's a way we can work them out tomorrow. Nice job, group.
Given that operations with decimals is a very procedural driven skill, and teachers often give students a worksheet on adding decimals, a worksheet on subtracting on decimals, and so on and so forth, I was very pleased that this task allowed my students to practice the procedural side of computing decimals, but it also brought in their creativity, especially with how they grouped their 3 equally matched teams. Students took procedural steps and used them in a real-life situation, something that they couldn't have done without the conceptual understanding of what a decimal represents. I was so pleased on how I saw students creatively grouping and using averages, rounding decimals, and even bringing in other ideas such as comparing decimals with which one was the fastest time versus a slower time, and also using inequality symbols, all of which are usually isolated in their own skill or in their own task. But at this task, the crab walk relay task, brought all those together, which gives me a sign that it was a rich task and that it was clearly implementing student reasoning, problem solving, and engagement. Overall, it was a very successful activity.